In part 2 of this lesson, we're dealing with two examples that have fractions. If we look at example number 4, we have the square root of two numbers being divided. So we can actually use that second property that we looked at. We can distribute the square root over the division bar. So that's where I want to start my problem. I'm going to distribute the square root to my numerator and to my denominator. Now at this point, to simplify, I need to get rid of the square root in my denominator. I need to do something called rationalizing the denominator. The denominator is the bottom number in a fraction, and rationalize means get rid of the square root, get rid of the irrational number. To do that, I'm going to multiply by 1. Now I can take any number and multiply by 1 and keep equality. And since this is a fraction, I'm going to turn this 1 into a fraction by putting it over 1. Now I haven't changed this value yet because I'm still multiplying by 1. But if you notice, I can rewrite 1 as anything over that same thing. So whatever I have in my numerator, I can have in my denominator, and I'm going to keep equality. So I'm going to change my numerator and my denominator to be the same thing. And in this case, I'm going to switch my numerator to the square root of 12 and the denominator to the square root of 12. And I got that square root of 12 by using this denominator. So if you look, the square root of 12 divided by the square root of 12 is really just 1. So I'm not changing values, I'm just changing the way this 1 looks. At this point, I'm going to multiply fractions. To multiply fractions, I multiply straight across. I'm going to take the square root of 7 times the square root of 12 over the square root of 12 times the square root of 12. Now to multiply my numerators, I have two square roots, so I'm going to rewrite it underneath one square root symbol. And my denominator, I have two square roots, and when I multiply two square roots, I can rewrite them underneath one square root. And now I can do that math. 7 times 12 is 84, and 12 times 12 is 144. And if you look at this point, I thought I was supposed to rationalize the denominator, but there's still an irrational number here. But if you look, 144 is a perfect square. If you've done your math right, every time you rationalize the denominator, you should end up with the square root of a perfect square. I can take the square root of 144 and get 12. So it looks like I should be done at this point. But there's one more step that I need to do. There's one more thing that I need to check. I need to look at this numerator and make sure that 84 is not divisible by any perfect squares. So I use my list of perfect squares to find the biggest perfect square that divides 84. The biggest perfect square that divides 84 is 4. So I need to worry about just my numerator now and rewrite 84 as 4 times 21. And then I can distribute that square root in the numerator to the 4 and to the 21, and then simplify the square root of 4 down to 2. One final step, I have a 2 and I have a 12. 2 divided by 12 is 1 1/6. So I can simplify this 2/12 down to 1/6. So my final answer simplifies down to be 1 square root of 21, which I'm just going to write as the square root of 21, over 6. That's my simplified answer. Notice that 21 and 6 are both divisible by 3, but I can't divide this 21 and this 6 because this 21 is underneath the square root and this 6 is outside of a square root. I can only divide when my two numbers are outside of a square root. In example number 5, I'm going to start by distributing to each numerator and each denominator. And then I'm going to multiply my fractions together. Square root of 15 times the square root of 3 over the square root of 8 times the square root of 4. And I multiply my numerators together. Square root of 15 times the square root of 3 becomes the square root of 15 times 3. Square root of 8 times the square root of 4 becomes the square root of 8 times 4. And then I do that math. 15 times 3 is 45. 8 times 4 is 32. Now at this point, I'm right here. I need to rationalize my denominator by multiplying top and bottom by the square root of 32. And again, multiply my fractions, multiply my numerators together, multiply my denominators together. To simplify my numerator, I can rewrite it underneath one square root symbol because they're both square roots. Same with my denominator. Now I can do that math. 45 times 32 . 32 times 32. Now if I've done my math correctly, even though this is a huge number, 1024 should be a perfect square. I should be able to take the square root of 1024 and get an integer answer. And I do, 32. So I have the square root of 1440 over 32. Now at this point, I'm right here. My denominator has been rationalized. Now I need to simplify my numerator. I need to find the biggest perfect square that divides 1440. Well, if you look, I have a 0 at the end, which means that this number is divisible by 10. I really have 144 times 10. And 144 is a perfect square. Distribute my square roots. Simplify my perfect squares. Square root of 144 is 12. Now at this point, I'm right here. 12 over 32 can be simplified. 12 and 32 are both divisible by 4. So I can take 12 divided by 4 and get 3, and take 32 divided by 4 and get 8. Excuse me, this should be a 3 right here. 12 divided by 4 is 3. 12 32nds simplifies down to 3/8. So my final answer is 3 square roots of 10 over 8. I know that I'm done when my square roots have been simplified, and I've simplified my fractions out here.